Via SB, I warmly welcome you all to EduCatalysis pre-event of YES 2025. We are here for the talk session on underwater robotics. We are honored to have with us Mr. Kailash R S, Junior Researcher at IIT Tirupati, who will guide us into the fascinating world of underwater robotics, a field that pushes the boundaries of innovation and exploration. I also extend my greetings to all the participants joining us today. Your presence reflects the true spirit of IEEE. With that, let's begin the session. Please join me in welcoming our speaker, Mr. Kailash R S, and over to you, sir.
Hello everyone. Hope I am audible. Yes, and visible also. Thanks. Yeah. So before starting, I would like to know. I got information that most of the participants are in like second and third year. I would like to know like your backgrounds, like ECE, mechatronics, mechanical, and stuff. Maybe for mechanical, give a thumbs up. Maybe for computer science, give a heart, and maybe for electronics background, give a cap. So I can give relevant examples and your with your field of yeah, with your field. So yeah, let's get started. I think most of you are from CS background, I guess. Anyways, good. So to my background, I did mechatronics engineering. Like I have bachelor's in mechatronics engineering, and I have 2 years work experience in a startup from IIT Madras. And right now I am junior research fellow at IIT Tirupati. Like in the startup also, I have worked in marine robotics. Just pressing the screen. Screen is visible, right? Is presentation visible?
Yes, the presentation is visible.
Okay, let's start. So yeah, there is a vast definition of robotics, and it can be applied to like each application has its own definition. So this is the overall definition of robotics. It's a programmable definition of a robot. It's a programmable machine capable of sensing its environment, processing information, and performing an action and to achieve specific tasks. The key aspects is sensing, computation, actuation, and control and autonomy. Sensing, we will use sensors such as cameras, IMUs, and sonars and stuff. Like these are all current sensors which I am working on, so I have mentioned it. And computational side, currently many people which I see and papers and LinkedIn posts as well, they often come up integrating AI and ML, but not mostly. It's AI is not. Previously AI was not in, interconnected, but right now everybody is uh, having AI in their work. So that's one aspect. Actuation, like I think mostly because you are from second and third year, mostly you will be aware of actuators and stuff. So for any robotics, motors are important, and for underwater robotics, thrusters are the major aspect. And control and autonomy, basically developing algorithms for its navigation, planning, and stuff. So this is the overall view of robotics. Robotics has several fields such as industrial robots, field and service robotics, and underwater comes under field and service robotics. So and in field and service there are many aspects. These three are major aspect: field and wheeled robotics, aerial robotics, and underwater robotics. So as well as there are medical robotics as well as space robotics, which we are not going to discuss deeply in this session. And this session shouldn't, I mean, I thought, I don't want to make it more technical, so I just want to give an overview and like just a perspective of where research is currently in overall world and stuff. So, I mean, the applications of land robotics is like people can see like, delivery robotics from Amazon as well in warehouse and stuff. Aerial robots is one of the famous in all of these uh, categories because it's comparatively cheap uh, and application aspect as well. It's hobbies to many engineering students as well as overall world. I mean, for people, it is I mean, it's useful for everyone. And underwater robotics, uh, as name suggests, it's operated in dense medium and mostly comparatively it's a very expensive domain and mostly used for oceanography, defense, and offshore inspection. So, going deep into the differences, the medium I have already discussed, and challenges the land robot which faces is obstacles and uneven terrain. Uneven terrain. To overcome these aspects, people have different kinematics in place of like different wheel structures. And coming into the challenges faced by the aerial robots are gravity and aerodynamics. And for underwater robotics, it's buoyancy, drag, and pressure. So buoyancy, in the sense, I like to I mean, once again define or make you give a reminder to buoyancy. It's based on Archimedes principle, which is the force exerted towards any system, which, uh, according to the volume displaced by it. Not a proper definition, but I mean, I just want to remind you on, because it's a key aspect in designing the underwater robots or any marine system. And comparatively, the energy requirement also plays a role. And requirement for land robotics is moderate, and aerial robotics I mean, they have given it high, but uh, r- currently there are many research and stuff towards the battery to develop the endurance of the aerial robot. So comparatively, it can in short period it can also be moderate. And underwater robotics, it definitely has a high energy requirement. My current project is also towards it, but I will discuss it later. And communication aspect, like, everybody has idea that uh, we can communicate with Wi-Fi and radio with aerial and land robotics as it's easily available. But the challenge in underwater aspect is there is no radio communication. There is only acoustic communication, and accordingly, they will the communication aspect is towards optical and data. There are different communication aspects towards it. Basically, with sound, we will communicate. And application, as I have discussed earlier, it's just mentioned by me. And so to redefine underwater robotics is it's a 6 DOF remote controlled or autonomous submersible vehicle which can be controlled and navigated to accomplish underwater tasks. So just defining it, 6 DOF is like 6 degrees of freedom, like XYZ, and like let's assume it's a three-dimensional XYZ and rotational about the same XYZ axis. So it comes around six movements, and these are called 6 degrees of freedom. And so why underwater system is important is basically uh, this image, I mean, gives you an overview that we Okay, so before explaining this, I just want to again know, just want to make this relevant to you. Like, I think there are around 25 people here. Like, how many of you know swimming and like have swim, like, learned swimming and have like, swim? Just give a thumbs up. Okay, I think around quite a few know swimming. So just uh, okay, it's fine. Relevant to you that when you have learned it, you will start swimming around 3 feet, and deep down you will, after you learn techniques, you will swim in 6 feet. But the thing is, the difference you can see is it's easy to swim in 3 feet and it's tougher to swim in 6 feet. The and the energy requirement is all, if you will also be tough because the acting upon the body will be more. So there is a thumb rule that for each 10 meters, the pressure acting on this body or a system increases by uh, 1 bar. So when you go deep, the pressure increase as the increases. So considering uh, that aspect, human body can only take up to 60 meters. That is like we can only, our body, if uh, maximum can only take 6 bar pressure. So there, till that only human divers go with oxygen and other equipments as well, oxygen pack and other equipments as well. So, and then till 400 meters surface supply diving can go, and like till 600 meters people can push with uh, with other equipments. And I mean, recently Mission Impossible Tom Cruise has done it, so it is possible. But uh, with it also has expensive thing and stuff. High training is also important. Coming to the technical or engineering aspect, to the vehicles, uh, like up to 3 kilometers, remotely operated vehicles can go, and till 6 kilometers, observation belt can go, and submarine is the advanced system in entire marine engineering. It can go up to 11 kilometers. So yeah, so why underwater robotics? Uh, there we use oil, and there is a offshore system which has a heavy pipeline and stuff. So demand for pipeline survey and inspection and acoustic, as well as to install underwater pipelines. And if we have a system, we also need to maintain it. So like periodic checking and of installed pipeline is also an important aspect. And and there are oceanographic application, and which people easily can't do it. So, and the and here you can see the comparative comparison between human divers and underwater system or underwater robotics is humans have high maneuverability and tactile sensing and cognition. Okay, if we got stuck in a situation underwater, we will be easily able to think and come out of it. Not as shown in movies, but it is quite possible to, compare to a robot, we can escape from the situation. And limitation is, as I told before, I mean, pressure will be more, so physically it will be exhausting, and working depth is also limited, and energy as well as time is very limited. So we can't, we will, when we run out of oxygen, we can't be there. We have the endurance till the oxygen pack is there. And underwater robotics is are intended to replace human beings from dangerous. It's vice versa. It's advantageous to replace human as to overcome the limitations. And the other advantages, the maybe some errors made by humans are also uh, eliminated. And unique challenge, before that, just a second. So again, going into it, unique challenges for designing or developing an underwater system is the medium. As I just reminded you about Archimedes principle, buoyancy is important, and buoyancy management is critical. Basically, how what happens is, we say we have three conditions. So it's neutrally buoyant, positively buoyant, and negatively buoyant. If a system is neutrally buoyant, it will be on the surface. If it's positively buoyant, the system will come up to the surface, and if it's negatively buoyant, it will go down. I mean, it go down to the base. So we play with the buoyancy to make our system to go down and come up. That's how we will plan a mission and execute our task. And and medium properties, underwater system, as well as high density and drag. So if people from mechanical background will come to know, but anyways, we can also understand what's drag and lift and other hydrodynamic uh, terms as well. And important communication aspect is, radio waves cannot travel, so we will have only sound waves and acoustic systems. So basically, we will mostly use sonars and other similar uh, models as well. And energy requirement, it is high because the ocean is vast. It's 70% of the earth is based on ocean, and till now we, with these many years of running the ships and stuff, we have only covered around 5% of the ocean. We have the knowledge about only 5% of the ocean. Remaining percentage, we don't have idea. And the I mean, countries and research companies are towards it, and different to find the resources and stuff. We will come to that point later. And and navigation aspect, GPS is unavailable, so we will use advanced sensors and stuff, such as inertial navigation system, Doppler velocity logs, and acoustic positioning. So as I mentioned previously, this is an expensive part. The sensor is also expensive, such as INS comes around 3 lakhs, Doppler velocity logs goes around 13 to 14 lakhs, and acoustic modems and stuff, it's also towards in lakhs. And and major design constraint is, it should be leak proof. I will give a real world failure model, I mean example as well, coming in next slides. And material used for it and stuff should be corrosion resistance, as well as it should be useful for the long operation as well. And diving into the classification of underwater systems or vehicles is manned. So manned system, we all know about submarines, and there is another manned system, which is human operated vehicle. And in unmanned systems, uh, we have towed vehicle, remotely operated vehicle, unmanned untethered vehicle, underwater gliders, bottom crawlers and folds, and autonomous underwater vehicles. So, I mean, these topics marked in red, I will just explain you deeply, and I will also come to underwater glider, which I am currently working on at the later end. So, human operated vehicle. So, this basically uh, this vehicle is used for deep ocean exploration and research, and the key feature is that it should be pressure resistant, and endurance should be more compared to the other underwater systems, such because the human load is also acting upon this uh, system. So uh, it the battery capacity should be more compared to the other system, and as it also has direct human observation, safety of human is very important. And the major examples are of an HOV is DSP Alvin, Shinkai by Japan, and Geolong by China, and currently NIOT at Chennai, India's. They are developing Matsya. Uh, it's the aspect of Gangayan. So I had an opportunity just to visit NIOT, and I had a view had a view on Matsya as well. Like there, and I want to give an example. So this is the famous example which failed. Ocean Gate observation. Uh, there is a Netflix documentary. So like I just want to know how many of you have seen that Netflix documentary on this Ocean Gates Titan. Have you? You can give thumbs up. People in line, am I audible? Okay. So have anyone seen the Netflix documentary? No. I hope you haven't seen it. I suggest you see when you have free time. Uh, so the documentary basically gives an overview of how they failed. How they failed. So, and to give motivation or overview of how a system will should be developed. To give an overview of the documentary or the is like they developed a HOV where it took 5 years for them to develop it, and still it failed after like 70 days or so. So they did the error, and they tried to cover it, but because of it they failed. Seeing the documentary, we will know how a real developing a product and testing of it is tough. Tough, uh, not a better word, but uh, it gives you an overview of how real engineering works and what aspect you should take care before developing a product or on testing it and stuff. And remotely operated vehicles, this is used from I think 2000s or 2005. From it, it's very famous for all ocean oil companies and offshore system companies which use ROVs for their pipeline inspection as well. ROVs are extended. Their application is also extended by research companies for like a famous example is near Australia. They use ROVs to uh, observe the coral reefs in their country. So basically, the difference is the main aspect of a remotely operated vehicle is like it's playing. There will be a human. It's a hybrid system. They will control it with a joystick, so it's like playing a game, but it's very expensive aspect as well. Having a ROV operator is in lakhs for a few hours of time, and you also can think of being a ROV operator. Just a career tip maybe. Basically, it has a tether vehicle which is connected to a joystick, and uh, it can be controlled, and it it is capable of precise intervention task, and it can give high resolution feedback, as well as it can be manipulated and task. So because of it, task completion is comparatively easy, but the depth of operation, as I mentioned in previous slide, it's only 6 kilometers. Famous examples is Saab Core, it's from Sweden, and Schilling UHD. And ROV Jason is WHIO it's US MIT's ROV. And next, it's autonomous underwater vehicle. It's unmanned operating vehicle without data or real time control. So as the name suggests, it's autonomous. We will pre-plan uh, the operation, and the system executes it, and it's used for mapping, survey, and oceanographic research, and it can go to the deepest point of the ocean, and uh, can collect the data as well. The aspect we need to see is it has only limited onboard energy, so it can run only half a day. So I also attended a recent talk given by a researcher from University of Tokyo. They used the AUV for their observation. We'll come to that aspect. What application they have used it and stuff. And famous example is Remus from St. Woods Hole's Oceanographic Institution, and Hugin. It's by Kongsberg, famous company from Norway, and Autosub as well. Hugin, I've also seen it in real time. So to give you overview on current technology trends, as most of you are from computer science background, you can read papers towards it, and I think uh, and currently from Sweden as well, many papers have come that uh, people are working towards learning based control, adaptive machine planning, and online fault detection, and many, as mentioned, uh, people are working with AI. So there in an aspect such that with low power GPUs or SoCs, how we can make have a AI on less sophisticated GPU such as Raspberry Pi and stuff. In the perception and sensor fusion aspect, so currently one of my aspect is to combine DVL and INS data, and there are multi-beam and side scans sonar for deep perception and water column, and communication aspect, as uh, told before, that currently acoustic modems is majorly used, and optical links are for short bandwidth range as well. And and there are many papers coming up with swarm technology as well, like combining AUV with AUV is autonomous underwater vehicle, USV is unmanned surface vehicle, and UUV is unmanned. They also combined with aerial vehicle as well. So communication and this is swarm technology. You can also read papers on it. So yeah. And currently on endurance aspect, gliders, which I work on it. Glider is basically used for uh, lower depths and hybrid AUV gliders as well. And I have also helped another project from IIT Madras. So they also come up with they are working on bio-inspired fish. Uh, uh, so it's biomimetic, basically biomimetic applied into underwater system. So yeah, these are the current technology trends and active research topics to give you overview. So these are the current research areas. Many researchers work all around the world. Long-term drift-bound navigation without GPS, aided terrain-aided SLAM, and real-time 3D seafloor mapping structure reconstruction. It's famously, I think, University of Sydney is working towards 3D reconstruction of the underwater, coral reefs and stuff. Intervention and manipulators. I think few years back there are, robots developed by University of Singapore and stuff. So they have underwater robot and manipulator. So they are developing. They have developed and executed manipulator with underwater manipulation task in underwater environment. Which is autonomous, like it's pre-programmed and it can execute the task with feedback and with feedback of the camera as well as sonars and stuff. And as mentioned, swarm or cooperative task is currently a big research aspect. And digital twin is also coming up, is also applied towards the marine system side or underwater robotics. As I mentioned, uh, it's an expensive task. So make, coming I mean making digital twin also coming into the aspect or the perspective makes the cost, cuts down the cost as well. And health, robustness and safety aspect, health monitoring, fault tolerance control, verified autonomy. So these terms basically are for the safety aspect of the robot itself. So if there is, for example, if there is a leak, so we will also have a leak sensor in our system. So if there is a leak or if the battery endurance is down, and different aspect, different scenarios where a robot can fail or go underwater, drown, we will program it towards it, how in that kind of situation how a robot should react and how it can be saved. So research are also going on in that aspect as well. And on the global landscape, these are the famous labs and papers, important papers which I have read and good. I have also applied and stuff. I also have few contacts in from Tokyo, Sydney, and I didn't mention Southampton as well. So yeah, I will also share the slide. You can have a reference for it. And again, mentioning application driving the research is offshore and wind and oil gas inspection. It's mostly use in people from Dubai and Scandinavian countries apply. Use for this application. C4 mapping and cables archaeology and hazards from Australia. They try to address it in my perspective or the paper I have read from it. And all and environmental monitoring, defense and security, disaster as well, like it applies for everyone. All over the world, they particularly address these application. And open challenges and opportunities, I mean, people like you can also think of read papers and come up with a problem statement towards reliable communication, and hydrodynamics and disturbance estimation in real time. That's a good topic because people from mechanical background can understand what's hydrodynamic and its its problem. And standardized docking and payload interface across vendors. So this is an important aspect towards cost cutting as well, because when so I want to give an example, like, so when you are deploying an underwater system such as an autonomous underwater vehicle AUV, what we will do is we will take it in a ship and deploy it in region where we want to take data from. So for example, let's say it takes around 6 hours to dip, do the task and come up to the surface. It takes around, let's assume on overall it can take around 7 hours. So for 7 hours we need to have the ship on surface, and and people on board as well, and people to I mean take back the I mean make the AAV to take the AAV from the surface to the boat as well. So to give an economic aspect, taking a ship for a day or stuff, it will take around, minimum cost is around 30 lakhs, and we also need to pay humans, people as well. And so an economic aspect, that's an important uh, challenge to address as well. So we need to plan so in perspective, we need to plan, make a good plan how AAV should execute, and uh, easy point where it can be means it can be stayed, so we can after some time we can send people and retrieve it back. and and trustworthy autonomy is like, autonomy is basically autonomous system without human intervention, and stuff. Trustworthy autonomy is in uh, so in overall engineering, these aspects also as comes into picture, such as certification, ethics, and privacy. I hope you will all, these topics will come in your maybe final year papers or something and stuff. And this is important point: scalable data pipelines, that's raw sonar data into actionable map in hours. So 3D reconstruction takes days and days of time. So uh, efficiently, how quickly efficiently, as well as how much quickly we can make a 3D map or from a raw data, it it makes the problem simple. So we can also think of how to address it, and people are also currently working on towards it also. And my current project, it's based on a patented technology called Roboy, which is an autonomous underwater glider. So the difference is, uh, so underwater glider is a part of uh, autonomous underwater vehicle. So the difference is, it has long endurance, and it is used for only less depth. So yeah. And the Roboy, is which is for robot buoyancy. This uses change of volume concept. So as I mentioned, we play with buoyancy. Uh, we can buoyancy is basically displaced volume by mass. So I'm going in a technical term, I mean into technical aspect right now. uh, so basically, to change the system to make it a negatively buoyant system, uh, we need to change the weight of the system. And so buoyancy is okay, buoyancy is basically displaced volume by mass. So we can either change the mass or change the volume. So changing the mass is done by having a pumping system to take the water in from the water in. Let's assume an example such that the displaced volume is 100 kgs and the weight of the system is 100 kg. This is called neutrally buoyant system. Okay, and when we pump in the water, let's assume we are pumping it for 3 kg. This system becomes negatively buoyant and it goes down. And with help of pressure sensor and external sensor, we know that okay, our task is to go to 10 meters depth, and we know that we are at 10 meters depth. We program the onboard computer such that okay, at 10 meters we need to pump the water out. We pump the water out, the system becomes positively buoyant, and it goes up, it comes to the surface. So this is in change of mass concept. My The current project which I am working on is change of volume concept. Basically, we will use a metallic bellow to change the volume such that here, for the same example, the buoyancy, when we change the volume, so in my case we increase the volume of the system so that the buoyancy is 103 kgs and mass is same as 100 kgs. I mean, when we expand it, it comes up, and when we compress it, the buoyancy is maybe 97 kg, and the system, I mean, weight is same, so the system goes down. And here we have wings as well, so it can achieve a uh, seesaw wave. So I'll just show you the video later. Screen is visible, right? Can somebody just tell me it's visible or not? Video is visible, right? Can anyone give thumbs up? Okay, good. So uh, just want to explain how we will develop an underwater system. Basically, we will initially develop a mathematical model. When you read about underwater system, you will definitely understand what are these variables as well. And we will have a simulation result, and then we will execute it. As I told, the metallic bellow change of volume concept. This is the metallic bellow, which you see on the screen. This is a compressing, and this is expanding. This is how metallic bellow will be. And this is a patented technology. I am working on an advanced project with it. This is the initial prototype they have developed. My seniors are like my professor as well. So yeah, I will also share the slides to Jnana Prakash and as well as Aldrin. You can go through it and have a reference to the paper as well if you want. And thanks for listening, everyone.
Thank you, Kailash. The session was really insightful. So, before we move on, is there anyone who would like to raise their doubts or would like to have a discussion?
Yeah, you can ask. You are free to ask any question. Not an issue. I will try to address it.
If you are facing any difficulties to open your mic, you may type it in the chat box also.
This is I just want to mention. This is just an overview of underwater systems. If we want to go into technical, it can take weeks to explain it, and you want to make you understand it. Uh, make you understand it. So, yeah, people who are also interested to work on this as well, you can contact me. I can maybe check with my professor to take you as an intern and stuff. Yeah, the PPT will be available. I will share it to the person of contact. Any other questions? So, how can robotic machine control the pressure underwater? So this is, it can't control the pressure underwater, but it can withstand. So I think I have answered it. So we need to develop a mechanical system or the materials. We need to use the materials which can withstand the pressure and the system as well. Currently, so mostly people will use stainless steel 316L, titanium, and similar materials towards less weight and which can uh, withstand the pressure. That's one aspect. And overcoming the pressure is we use thrusters, and uh, th- uh, that's when thrusters comes in. And in my project, we use linear actuator to change the volume. So we need to so I choose the linear actuator which can withstand the load to our requirement. For example, our linear actuator can withstand this. As I told, it's very less depth. It can go. The requirement is only for 100 meters. So my actuator, which I chose for this project, it can withstand the pressure up to 100 meters. So 10 bars pressure it can withstand. As well as we need to design such systems such as leak proof and choose the materials accordingly. Hope I answered you, Abhishek. Yeah, and then so unpredictable waves or flow of water underwater. Yes, that's a great question. Like recently, around maybe March, I gave a presentation. I also got the same question as well. So some it's as you have mentioned, it's unpredictable. That gives the problem as well. But there are underwater currents and stuff. But on the system, we will have a INS, inertial navigation system, a Doppler velocity log, and stuff. So we need to design a system such that it doesn't affect the, break the system. That's on design aspect. But as flow of water and stuff, it gives the drift to the system, so that to address the problem we will address in a way such that we can identify its location as well. There is no GPS, but uh, we have to program accordingly such that if there is a situation it should come up, and if it's on the surface we can anyways locate where our system is. And flow of water unpredictable ways, this is also a research aspect as well. Currently I think people are working towards. I think I answered your question, right, Sinam? Sinan, sorry. Okay, this is a good question. I think you have went through the Titan aspect as well. Implosion is a great example from Ocean Gate's failure. There only people, many as people came to know what is implosion. It's compressing of a system. Uh, it happens when there is a leak, and so they famously, there is a political as well as some uh, corruption aspect as well for the ocean gate to fail. And implosion basically happens when your system cannot withstand the pressure. uh, so as I told, when we for each 10 meters 1 bar pressure will be there, and around 1 kilometer you can calculate the pressure, and it's not in my top of my head, but the example when Ocean Gate failed, it had, the Ocean Gate's HOV imploded. It has the weight of like I think 10 or 10 elephants, as the weight of 10 elephants having into the system, so it will just implode, compress. So if there is a pressure leak and stuff, there will be an implosion. I think mean, did I answer you, Hamda, right? Hamda. Sorry for my pronunciation. Objects, deep sea. So currently, towards the they use side scan sonar or sonar as well. So to get the overview of the surface, underwater surface, and with that overview on the map, we will know. Okay, we will know where we need to look. So we will program the robot accordingly such that it should look on to the particular area or location, and we have a sonar and uh, camera as well. As well we can have it and program the robot accordingly to uh, and plan our path accordingly, and we can program it and uh, check for shipwrecks as well as missing objects in the deep sea. It has planning, mission planning aspect as well, and then with sensor integration and feedback. It will record the data, and when it comes to the surface we need to retrieve it. Retrieve it meaning we need to take the data from the uh, storage from our storage in the robot from to the our laptop or a server somewhere. Did you get that point right, Malavika? Uh, I don't think so. It's harmful to the aquatic species. I'm not from a biology background. I stopped it from my 10th. To my knowledge, it shouldn't have any. It should not be any, harmful to the aquatic species. Like people are using sonar from. 19th century. I mean, I don't know, from last century as well. So they use it to take the data and stuff. Till now, I haven't read cases as well. It's harmful to the species, aquatic species. So to Abhishek, I don't have proper idea. I think that's my answer.
Okay, so since there are no more questions, I think we can move forward.
Yes,
Before
I
we
think the last
formally
question is there. Will
okay,
will robot record sound from underwater? Yeah, it can if it have a proper mic and stuff. That aspect I haven't looked at, but it can. It is possible to record sound from underwater. Praveen, Pravina. Yeah. Yes, Aldrin.
I hope that was the last question. Is there anyone remaining to raise their doubts? Okay, so it seems like no one else. So let's move forward. Before, okay, there's one more question.
Yeah. Since most of them are including the stuff. Okay, it's not a question. It's a suggestion or perspective of them answering to my answer. Okay, I will also look on to this harmful aspect to the aquatic species as well. Yes, ma'am. Yes, Alden, you can go ahead.
Okay, so let's move forward. So, before we conclude this event, I would like to make a few important announcements. The first one is that all of you please make sure that you fill the feedback form which will be shared in the chat box soon, because it's really important for you guys to obtain your participation certificates. And the next announcement is that we have an idea pitching contest coming soon, and the topic for the idea pitching will be underwater robotics. So all of you who have attended this session may try your hand in that competition as well. So it's my duty to say thanks to all of you who have cooperated with this talk session. First and foremost, I would like to extend my heartfelt gratitude to our distinguished speaker, Mr. Kailash R S, who is a junior research fellow at IIT Tirupati, for delivering such an insightful talk on underwater robotics. Your session has broadened our perspective on this fascinating domain and will surely inspire many of us to explore new possibilities in research as well as innovation. So, thank you so much, Mr. Kailash.
Thanks, ma'am. And also, I request like people who can turn on the camera to turn on. So I'll just take a screenshot for my own memory and for LinkedIn post as well.
Now, I would like to sincerely thank the team of IEEES as well as the Link team for bringing up this platform of learning and collaboration. And I would like to thank the members of IEEESB NIT Calicut as well as IEEE Education Society Kerala chapter, and my own teammates from IEEE Education Society Sahadaya SBC for organizing this wonderful event and taking care of everything from registrations to the conducting of this event on GMeet today. So thank you all the organizers and thank you all the volunteers. And last but not the least, I would like to extend my deepest appreciation for all of the participants, because your active involvement as well as your enthusiasm is what truly made this day memorable. So thank you all the participants. So, with that, we formally conclude today's talk session. So, thank you everyone. Wishing you a wonderful future ahead. So, thank you.
Yeah, just a second. I'm just okay. I've taken it. Just take. Yeah, thanks everyone for the photo as well. Yeah, thanks.